We're going to provide some background about the fertilizer industry in this module, and we're going to go over what ingredients or what are the basic ingredients of fertilizer, some of the supply and demand characteristics of fertilizer, the processes used in producing fertilizer, and then finally ends with just some facts about fertilizer production. So that's the plan. Again, this should also be useful background for your case study, the ORSCOM SWOT 1 case analysis. The three major nutrients used in crop production is nitrogen, phosphate, and potash. And again, those are the three nutrients needed in crop production. And as a result, they're also the three major uh, production processes for fertilizer. There happens to be 16 other micronutrients needed for crop production. In general, in a lot of cases, most cases, those are not fertilized. So we primarily are going to look at the three big ones, nitrogen, phosphate, and potash. You can see over in the lower right corner estimates of consumption in 2010 as projections moving forward. In 2010, nitrogen was used on 102 million tons was used of nitrogen, 39 million of phosphorus, and 27 million of potassium or potash. All of those ingredients are projected to grow over time, 102 million for nitrogen up to 105 in 2011 and 112 in 2015. They're projected to grow because we are increasing crop acres, and those increased crop acres are occurring because of biofuels demand, as well as increased standards of living in China and the Far East. Those increased living standards then lead to increased consumption of meat, which then leads to increasing consumption of crops by the animals, which then increase the need for fertilizers. Again, nitrogen, phosphorus, and potassium are the three major nutrients. Phosphorus and potassium are used by all crops. Nitrogen is only used by non-legumes, and the two major users of nitrogen fertilizer are corn and wheat. Some basic fertilizer facts. Fertilizer use is directly related to the land area or the acres or hectares in production. So as acres go up, fertilizer use will go up, and that you can adjust fertilizer use on individual acres, but the big factor that causes swings in fertilizer use are acres in production. Developing countries, many developing countries could improve yields of crops with higher fertilization rates. So, in many cases, the limitation to higher crop production is the lack of fertilizer. And just another fact is that China and U.S. use a great deal of fertilizer, and the table to the right illustrates this by showing nitrogen-based fertilizer. China and the U.S. are the big two. Again, those two countries use nitrogen on corn production as well as wheat production. Corn is a big user of nitrogen. You might note there that Brazil is down on the list. Brazil and South America are another big agricultural production region. The reason why they use less nitrogen than China and U.S. up to this point is that they grow less corn. Soybeans is a major crop in Brazil and South America. Nitrogen isn't needed. Nitrogen fertilizer isn't needed for soybeans. U.S. The U.S. uses fertilizer and also imports a large proportion of certain fertilizers. Here, this is shown for 2011. In 2011, the U.S. imported 54% of its nitrogen, not much of its phosphates, and 95% of the potash. 54% of the nitrogen, again, is imported. That also happens to be one of the reasons why individual companies are now looking at expanding fertilizer production in the U.S. Again, nitrogen gas prices have come down. causing U.S. to be a profitable place to or more profitable place to produce nitrogen, and hence the demand, the increased interest in locating plants in the U.S. Where the U.S. imports come from is listed on this slide. This data is the same 2011 data that was used on the previous slide. Nitrogen imports, the big country is Trinidad. 48% of the nitrogen exports come from Trinidad. Canada, followed by Canada, and then the Russian Federation and the Ukraine. Trinidad is again where a lot of the nitrogen imports come from. Trinidad has large supplies of natural gas. That leads to them having the ability to produce nitrogen fertilizers. The picture below shows a nitrogen producing plant in Yara, owned and operated by Yara International, and again that happens to be on Trinidad. But one of the reasons why Trinidad is now a source of much of the U.S. nitrogen is because of natural gas and exploiting that in Trinidad. Our potash imports come from Canada and the Russian Federation. Canada by far is the largest supplier of potash in the United States, with over 85% of those imports. A large portion of those imports is Potash Corporation of Saskatchewan, but again, 85% from Canada. Here we're looking at a slide that shows projections of, and this was done by the International Fertilizer Industry Associations, projections of uses of fertilizer, or more specifically nitrogen. Most of that again is fertilizer, but there's also industrial use as well as the supply. Supplies are projected to increase, and again that was done by the International Fertilizer Industry Association. So they're projecting that supply will increase primarily as a result of building new plants. This is a world situation. Some of those plants are being obviously built in the United States. A great many of those are being built in China. The widening gap between supply and uses may cause prices of anhydrous ammonia to decline. As was illustrated in the class, those have increased while at the same time natural gas prices have come down. That has caused nitrogen fertilizer to be a profitable venture. These increases in supply, you would expect that eventually that would reduce the profits of nitrogen fertilizer. That may cause there to be a first mover advantage, i.e. those that move first will be able to reap higher profits in the beginning periods. But if we do see large increases in ability to produce nitrogen, we may see softening of those prices, which will then lead to lower profits for the fertilizer companies themselves. Phosphorus or phosphate fertilizer is again produced from mine material. This slide shows the known reserves or estimates of reserves of phosphate, and this estimate was based in 2007. Again, most of the phosphate fertilizers used in the United States are produced in the United States. A large number of those are produced in Florida. North Carolina is also a place where phosphate fertilizer production occurs, as well as some in the upper Great Plains. But you can see we have in the United States a 1.2 billion phosphate reserves. Brazil, South America, China, Kazakhstan, Middle East all have reserves. The big one there is Morocco. Morocco has large reserves of phosphate fertilizer and could likely be a major supplier of fertilizer well into the future. One of the concerns that you also almost always hear with phosphate and potash is that eventually we're going to run out of phosphates, because eventually we'll run out of known reserves, and at that point in time we will see large declines in crop production. Whether you hear those arguments made as far as peak oil as well. Um, those arguments so far haven't come to fruition, and whether or not they will is an open question. But you do hear a lot of concerns about the known supplies of phosphorus. Potash reserves are shown in this slide. Again, these are known reserves, estimates of those known reserves, Canada having a large proportion of those reserves, followed by Russia. Belarus is in there as well as China. Again, you have the same concern with phosphorus, running out of reserves or running out of phosphate fertilizers in the future. Canada and Russia will obviously be large producers of potash fertilizers into the future. Another one of the concerns is that what happens if Canada runs out of reserves, and then we'll have to rely on Russia, and how stable is the former Soviet Union and Russia in its ability to provide those potash reserves. I want to take you through a couple slides now that just illustrate the process of nitrogen fertilizer production, and in particular anhydrous ammonia production. These are going to be shown on the next slides. These slides are taken directly from a presentation made by Jim Schallhorn from Terra Industries, and this was back in 2009. Since 2009, or after this presentation, Terra Industries was purchased by CF Industries. So Terra Industries is now um, part of CF Industries. This slide shows a nitrogen fertilizer plant, which was a Terra Industries plant, now a CF Industries plant. This one happens to be Oklahoma, but just does give you a feel for what that plant would look like. This footprint would be roughly a square mile, so it's a large industrial complex that would be involved in the production of fertilizer. The ammonia process itself involves taking nitrogen and three hydrogen atoms, combining them to produce ammonia. That chemical process of producing ammonia is fueled by natural gas, so the feedstocks to produce ammonia are natural gas and air. Now, obviously, you have to pay for natural gas. Hence, the need for and location of near natural gas supplies is important in locating a nitrogen fertilizer plant. A byproduct of the ammonia production process is carbon dioxide, and again here the natural gas provides the hydrogen atoms, air provides the nitrogen. A byproduct of that is carbon dioxide. Obviously, carbon dioxide or production of carbon dioxide has become a concern in recent times due to perceived threats or real threats of global warming caused by placing carbon dioxide into the air. While we've been describing the natural gas, or excuse me, anhydrous ammonia production process being fairly simple, it obviously isn't that simple. Again, just looking at the facilities involved here, you need good facilities. You also need good people running those facilities, making sure that the plant is running properly, safely, and efficiently. So while we aren't dealing with those efficiency issues here in this class, it is important to realize that making these processes work is not a given. Yet you can make them run badly if you put bad facilities or bad people or poorly trained people in those facilities, less than optimal results can happen. Between the fertilizer manufacturers and application, there's a distribution chain or distribution channel. Fertilizer manufacturers typically do not, or many of them do not own the retail outlets that make those fertilizers available to farmers. There's a distribution chain between those, and then there's a farmer application. The picture here shows the application of anhydrous ammonia. Just to give you a feel for what's going on here, anhydrous ammonia is stored in the white tank in the back. It's being applied by the blue piece of equipment in front of the white tank, and it's being pulled by the cat tractor in the front. Anhydrous ammonia is typically applied in Illinois and Iowa. It's applied in the fall and the spring, so we can make those applications both in the fall and the spring. Fall after the crop is off, and spring often before the plant or before planting occurs. Although it can also be applied after planting and in side dress fashion. Anhydrous ammonia can be moved by pipeline, barge, or train. Just some of the means of moving it. Trains are moving it by rail is becoming increasingly problematic because of railways' concern with moving anhydrous ammonia. Anhydrous ammonia itself is somewhat dangerous. If you get it, if you would get it in the eye, for example, it can ruin your eyesight. So it is a somewhat dangerous thing to work with. Anhydrous ammonia is one form of nitrogen fertilizer. There are others. You see three of them listed there: urea, ammonium nitrate, and UAN. All three of those, and there are other forms of nitrogen fertilizers as well. All three of those fertilizers, though, happen to be made from ammonia, so the process of making other fertilizers begin with anhydrous ammonia, and then you convert them to other nitrogen fertilizers. So, for example, urea is a combination of ammonia and carbon dioxide. Ammonium nitrate is ammonia plus nitric acid, and UAN is a combination of urea and ammonium nitrate. As an or this is somewhat important, as you could guess. Moving anhydrous ammonia can be problematic because it is a caustic compound. One of the ways to make it less caustic and move it is to make urea. You see urea there listed as a first fertilizer. So what you would do is then make ammonia first and then make urea. Urea is a dry fertilizer. It's a compound that you spread, so it's a granular type fertilizer. That makes it easier, for example, to load in boats and barges, etc. So one of the processes that you have seen is that, for example, there's nitrogen fertilizer plants in the Middle East. They make anhydrous ammonia, then they convert it to urea. That urea then is more easily exportable than anhydrous ammonia. Ammonium nitrate is again another form of fertilizer. You might remember ammonium nitrate. It was involved in the Oklahoma City bombing case, Timothy McVeigh. Ammonium nitrate plus a couple other compounds, and you have something very explosive. Then UAN is a final source listed here. It's a liquid that is easy to handle. One of the points, though, of this is that anhydrous ammonia, at least from getting N onto the crop, is one of the cheaper alternatives because you don't have to process it further. Two of the large nitrogen manufacturers involved in U.S. production are CF Industries and Koch Industries. If you're looking at these fertilizer manufacturers, they're typically large. They have the process integrated. By that I mean they have the process of producing fertilizer and its distribution integrated. And it's sort of interesting if you're looking at, for example, CF Industries or some of the other publicly traded firms. They tend to be single purpose firms. They're involved in fertilizer production and they haven't branched out into other areas. They tend to stay focused on fertilizer production. One other point about nitrogen fertilizers is that it is a commodity, and it, like many commodities, has a boom to bust cycle associated with it. For example, one of the concerns right now for expanding nitrogen manufacture would be that eventually there's a bust. One of the reasons why now we see pretty good, healthy margins for fertilizer companies is that we've seen an increase in demand for fertilizer. In recent years, nitrogen fertilizer production has been cut in the United States, largely because before fracking had high natural gas prices, so producing nitrogen fertilizers here was costly relative to other places. So now with the natural gas lower prices as a result of fracking, we have the ability to produce nitrogen fertilizers more cheaply here, but our current production capabilities are limited. And again, in the past several years, we have heard reports that we've cut the ability to produce nitrogen for fertilizer by about 40%. So that has been a sizable cut. When we get those nitrogen fertilizer capabilities built up again, the margins may not be there. Obviously, that's an open question, one that involves dynamics and would also give a first mover into this industry an advantage. As I mentioned previously, phosphates are mined, or phosphorus rock is a mined substance which then is processed with sulfuric acid to produce phosphate fertilizers. Most of the mines are strip mines. This shows a crane used in the strip mine. I had the opportunity, and these mines are located in Florida, in the United States, and North Carolina. I had the opportunity to tour a CF Industries mine. This is a crane, and the picture may not do a very good job of illustrating the size of the crane. You could put, and we did put about 5 people in that that bucket, and the bucket was about, if I stood in the bucket, there'd be 6 foot above me. So this is a positively huge crane. It's kind of cool to watch it dig out the ground and as well as the phosphate rock. I want to end this module with just some facts about fertilizer production. First, fertilizers were, and the synthetic chemical fertilizers that we've seen illustrated in this module, the nitrogens, phosphorus, and potashes, were one of the first steps in increasing world food production. It was the limiting factor often in increasing yields on land, and the introduction of fertilizers in the 1900s in these synthetic chemical fertilizers greatly increased our ability to produce food from an acre of land, or it increased our productivity. Just to give you an illustration of the process for phosphorus and potassium, if we take corn, soybeans, or whatever crop off of a field, whenever we take off that yield or that grain or the vegetable or whatever, there's a certain amount of phosphorus and potassium within that grain or that yield that we're taking off from that field. As we take that off, the soil phosphorus and potassium levels become depleted, and as those soil and phosphorus levels become depleted, yields go down. And the only way that you can counter that process is to put phosphorus and potassium back on the soil. There isn't really any other way to get it back on the soil. Prior to the introduction of fertilizers, you would typically see reductions in yield as the length of time a piece of land was farmed, and again, needed to get phosphorus and potassium back on that land. And synthetic fertilizers were part of the process that allowed us to bring those lands, those phosphorus and potassium back levels back to where they needed to be for optimal crop production. Second point is that we often hear concerns about phosphorus and potash in the future. There's a known reserve to them, just like oil. You may have heard of peak oil theory. We're reaching a peak oil and eventually we're going to erode or deplete the amount of oil that we have available to us. There's that same concern with phosphorus and potash. Again, whether or not those concerns turn out to be true or not is an open question. You'll hear debate on either side of that issue. Finally, there are environmental concerns associated with using fertilizers, and that may become a concern both to the agricultural sector as well as fertilizer companies themselves. Some of the concerns is that phosphates getting into water supplies, and the typical way that phosphates get into water supplies or water or streams in particular is through erosion. You have erosion on the land. That eroded land carries with it phosphate on the soil, and that enters into the water. Nitrogen environmental concerns are a bit more difficult, or nitrogen is also has concerns, and we'll illustrate some of those concerns on the next slide. Nitrogen control or nitrogen use is very complex, as illustrated by this slide, which depicts the nitrogen cycle. But nitrogen for plant uptake has to be in either ammonium form, the blue box right below the plant, between plant uptake. It either has to be in an ammonium form or a nitrate form. With synthetic fertilizers, we're putting on ammonium, making it readily available for plant uptake. Some of that ammonium will also will become nitrates through a nitrification process. So you put ammonium on the soil, it's available for plant uptake. It's also is converted to nitrates, which is also available for plant uptake. Unfortunately, also ammonium and nitrates that are available for plant uptake are also available for a couple things that aren't so desirable. One of those is volatilization. Ammonium can be placed into the atmosphere as atmospheric nitrogen, which actually is just returning it to the place where it started. But there are concerns about atmospheric nitrogen, and again, it's a greenhouse gas and concerns with climate change. Nitrates also can leach or run off. Leaching will perhaps and do allow nitrates to enter water supplies. One of the major ways nitrates get into the water supply in the Midwest is through field tiles. Water runs through soils in the spring after nitrogen is applied. That nitrogen or ammonium perhaps has been converted to nitrates that's readily available for leaching. It enters the tile systems and then goes into the streams. That has a number of bad environmental consequences. One of those is nitrates in the water supply is unhealthy. There's also some concern with nitrates reaching the Gulf of Mexico and causing the dead zone that exists down there. This is all to say that one of the concerns that the agricultural industry will be dealing with in the future and is dealing with now is how to control these environmental consequences from nitrogen fertilizer applications.